when I connect only a resistor, only an inductor, or only an capacitor. What is the behavior of voltage and current? They are always in phase. No phase difference between them. Plus phi, minus phi, additional phase not seen. One complete variation. So very clearly, the phasor diagram shows that voltage and current reciprocate each other in an AC circuit. Hello students, a warm welcome to my session 2 on the chapter Alternating Current. Before I proceed on with today's class, I will again re-quote a statement which I had done in my earlier class. The world today is very, very intelligent. We don't judge a fish by its ability to climb a tree. But if the fish has no potential to survive in water, yes, it is questioned. My dear students, the taratum to switch the accelerator is on. 4 months more to decide the criticality of your future. Again I say, press the accelerator. Things now have to gear up. Fine. Before I proceed on my discussion, let us recall a few topics that I discussed in my session 1, starting with the definition of alternating current. We told it is a current whose magnitude varies with respect to time. Alternating current andreno, strength of the current changes with respect to time as well as the direction also changes periodically. There is change in the magnitude, students, as well as periodic change in the direction. So as you saw in the previous class, it was a sinusoidal variation, simple harmonic variation of voltage or current with respect to time. 3 terms I recall here. The first one, what I call as instantaneous values. What was instantaneous values, students? The value of alternating current or voltage at a given interval of time. So we told at that instant, a kottiruvanta time interval alli define agtiruva AC current athwa voltage value. Idine navu instantaneous values ant karitive. I spoke about peak values, E0, V0, I0. What was the peak value? Amplitude value. It was the max maximum value. You couldn't have a value more than that. Maximum value of either alternating current or voltage defined over a half cycle, positive half cycle as well as negative half cycle. You have a maximum value over the positive half cycle as well as the negative half cycle. Therefore, I told it is the maximum value over one half cycle. Then what was mean value or average value, students? Again, average. Mean of what? Instantaneous values. I am computing or calculating the mean or the average of the instantaneous values defined over a half cycle again. And we very much spoke about phasors and phasor diagrams. With these basic concepts, I will be taking on my session 2 today, which I name as AC circuit containing a pure resistor. And this is a classical derivation for 3 marks. Very much often repeated, frequent agi 3 marks ge keluvanta questiongalu. Now, what we are intending to do here, I study 3 types of AC circuits. First, I begin understanding AC circuit with a pure resistor, then AC circuit with a pure inductor, and then AC circuit with a pure capacitor. What is the intention of these studies? Here, my entire motive is to understand the behavior of an AC circuit. Andre, how voltage and current behaves in an AC circuit when I connect only a resistor, only an inductor, or only an capacitor. So, my discussion here is to understand AC circuit containing pure resistor. Hagidre, pure resistor andreno? Sir, unpure resistor antlu irutta? Corrupted resistors antlu irutta? No. Pure resistor andre, it is a circuit which is connected only with a resistor. ಬೇರೆ ಯಾವ ಕಾಂಪೊನೆಂಟ್ಗಳು ಇರೋದಿಲ್ಲ. ನೀವು ಸ್ಲೈಡ್ ಗಮನಿಸಿದ್ರೆ ಐ ಡೋಂಟ್ ಹ್ಯಾವ್ ಅ ಕೆಪಾಸಿಟರ್, ಐ ಡೋಂಟ್ ಹ್ಯಾವ್ ಅನ್ ಕಾಯಿಲ್, ಐ ಡೋಂಟ್ ಹ್ಯಾವ್ ಎನಿ ಅದರ್ ಸರ್ಕ್ಯೂಟ್ ಕಾಂಪೊನೆಂಟ್. It is only a resistor. Therefore, we call such circuit as purely resistive AC circuits. Which means to understand, in my today's discussion, I will analyze how voltage and current behaves in an AC circuit which has only a resistor connected in it. What will be the characteristic relationship between voltage and current in an AC circuit which has only a resistor, pure resistive AC circuit? Fine. We'll start understanding the discussion. Now, I will consider a pure resistor of resistance R. Mat puna bari resistance na matra connect madidini. Adike adana pure resistive AC circuit ant karitini. So I consider a pure resistor of resistance R connected to a source of AC voltage V. So this is an AC source. ಯಾವ ರೀತಿ ಅದನ್ನ AC source ಅಂತ ಐಡೆಂಟಿಫೈ ಮಾಡೋದು? DC ಬ್ಯಾಟರಿ ಆಗಿದ್ರೆ a small line and a big line ಬರಿತಿದ್ವಿ, DC source. See, here it is a sine curve. Wherever I have a sine variation, it clearly means an AC source. So I have a pure resistor connected to an AC source of voltage V. The potential difference, ಏನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಫಸ್ಟು? Potential difference across the terminals of the AC in a time interval T. ನೋಡಿ ಮಕ್ಕಳ, ಬೇಸಿಕ್ ಆಗಿ ಇಲ್ಲಿ ನೀವು ಮತ್ ಪುನಃ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕಾಗಿರೋದೇನೆಂದ್ರೆ, the entire book work is to understand the variation of voltage and current, how voltage and current reciprocate each other in an AC circuit. The case now here is purely resistive circuit. ಯಾಕೆ ಫಸ್ಟ್ ಪೊಟೆನ್ಷಿಯಲ್ನೇ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು? ಯಾಕೆ ಕರೆಂಟನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು? ಓನ್ಲಿ ವೆನ್ ದೇರ್ ಈಸ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್, there is constituency of current. You apply some potential, there is flow of charges. That is what is current. So first I will characteristically calculate potential difference across the terminals of this AC in a time interval T, which means what am I calculating? Basic terms in recall madi. Yes, very good. This is nothing but I am calculating instantaneous voltage. I'm calculating potential difference at an instant of time t is nothing but instantaneous voltage at a time interval t. Instant of time t, instantaneous voltage V equals V naught sin omega t. Any instantaneous value V equals V naught sin omega t. What is V naught? I told a naught suffixal 0 barud takshana, it is the peak value. Peak value of what? AC voltage. V alva voltage. V naught peak value of AC voltage. What is omega? All of you know 2 pi f, which is angular frequency. So for any other two derivations, this is the same that we calculate first. Instantaneous voltage V equals V naught sin omega t. V naught peak value, maximum value of AC voltage, omega 2 pi f, what I call as angular frequency. Now, potential apply madidvi. At an instant of time t, V was the potential applied. Now there is a current I flowing through a resistance R. So what did my Ohm's law say? V equals I into R. So very clearly, this is from Ohm's law. If I is the current flowing through the resistor, then V equals I into R. I am sophisticating this study relationship between voltage and current. So V equals I into R from Ohm's law. Now substituting for V, what was V from equation 1? V naught sin omega t. So instead of V, I am substituting for V from equation 1, V naught sin omega t. V badlu ಏನು ಬರ್ಕೊಂಡಿದ್ದೀನಿ? V naught sin omega t, which is equal to I into R. Now, from this expression, I becomes equal to V naught by R sin omega t. Sir, I yak baradri? That is what I told. My aim is to understand how voltage reciprocates current. Equation 1 nal V sikkittu. Now I need to know I. So just substituting or modifying I is V naught by R sin omega t. Now understand, I replace this term V naught by R as I naught. Hag bardri sir? Ohm's law ಏನು ಹೇಳ್ತಿತ್ತು? V is I into R. So I ಏನಾಗುತ್ತೆ? V by R. Since I am defining maximum values, ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಸಿಕ್ಬಾರ್ದಲ್ವಾ? Peak value. So V naught by R is nothing but I naught. So V naught by R is the peak value of the current. Very simple ಆಗಿದೆ. V equals I into R. What was V? V naught sin omega t equation 1 ನಲ್ಲಿತ್ತು I into R. or I equals V naught by R sin omega t. V naught by R is nothing but I. But since I have defined peak values, maximum values, I naught is V naught by R, which is peak value of current. Now, my dear students, observe equation 1 and equation 3 for voltage sin omega t int bantu. Current again sin omega t int bantu. Is there any phase difference? Nenu helkotte angle allenadru plus 5 idya voltage ge? No. For current, do you get any additional factor? No. Equation 1 clearly says V naught sin omega t. Equation 3 clearly says I naught sin omega t. Andre, please to understand, here there is no phase difference between voltage and current. Illu sin omega t, there also sin omega t. Plus 5, minus 5, additional phase not seen. Therefore, we say, in any AC circuit with a pure resistor, applied voltage and current are in phase. ಒಂದು ರೆಸಿಸ್ಟರ್ನ AC ಸರ್ಕ್ಯೂಟ್ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರೆ what is the behavior of voltage and current? They are always in phase. No phase difference between them. This is an ideal family. ಒಳ್ಳೆ ಗಂಡ ಹೆಂಡತಿ. They correlate each other. So purely resistive circuit is an ideal family. Why? Good understanding between husband and wife, voltage and current, they don't go out of phase. So the conclusion here is, whenever an AC circuit is connected to a pure resistor, applied voltage and current are in phase. Now we will exhibit this variation or the result through a phasor diagram. What was phasor, students? Rotating vector which shows the relationship between voltage and current. See, the first curve, voltage curve. The second curve, current curve. They have to be in phase. ಇವೆರಡರ ಮಧ್ಯ phase difference ಇರಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ. So if you observe, voltage starts from 0, maximum value V naught for an angle pi by 2. Pi by 2 radians, it is attaining maximum value. Pi radians again comes back to 0. One complete variation for 2 pi radians. Current curve nodi, same thing should happen. Voltage and current should be in phase. See, current also starts from 0. Again, I naught for the same phase pi by 2. Sir, ಇದು strength vary ಆಗುತ್ತಲ್ವಾ? ಆಗ್ಲಿ, phase ಬೇಕು ನಮಗೆ. They have no phase difference ಅಂತ ಹೇಳ್ತಿರೋದು. Pi by 2 radians, voltage has also reached maximum value. Current has also reached maximum value. No phase difference. Again, pi, good. Both of them become 0. Again, for 2 pi radians, one complete variation. So very clearly, the phasor diagram shows that whenever a resistor is present in an AC circuit, current and voltage can never go out of phase. And again you see the phasor. Angle between voltage and current is omega t. Both of them, yes, in the same straight line. They don't go out of phase. So my dear students, in this session, very clearly you have seen how an AC circuit behaves when only a resistor is connected, how current and voltage are in phase, how actually an ideal family performs for a purely resistive circuit. We have drawn the phasor diagrams, the phasor. In next session, I will come back with AC circuit with pure inductor and capacitor. Until then, recall, study, be thorough. Yes, the time to ring the bells is on. We'll come back, meet in the next session. Until then, thank you.